Dear students, I am Santa, working as a physics faculty in Target English Medium School. Today, in this part of video, I would like to teach what is the momentum or linear momentum, what is its formula and what are the units of momentum, and also we discussed some example numerical. Example is nothing but some suitable numericals is nothing but which type of numericals. During the examinations they are asking based on linear momentum or momentum. That is mostly I will be try to cover in this part video from the chapter of laws of motion. Once again listen all of you. In the chapter of laws of motion, first we discuss the Aristotle hypocrisy. Later we discussed what are the Galileo's observation. Further we discussed who proposed the laws of motion and what is the Newton's first law of motion. After proposed by the Newton, after first law of motion proposed by the Newton scientist, he gave two important definitions or ideas to us. One is the force, another one is the inertia. That is very clear. But what is the inertia? Because of it is a new concept. So that's why inertia is nothing but it is depend upon the mass of a body. It is a property of every matter. That is also we clearly discussing that. And what is the inertia? How we are understanding the inertia is depend upon the mass of a body or matter of the mass. That is also we clearly explained. And later I will explain what are the types of inertia. Under that one totally three types of inertia are there. First one is inertia of rest. It is also called static inertia. Second one, inertia of motion. It is also called dynamic inertia. Third one, inertia of direction. These three we are discussing that. Now in this part of video, so directly we can come to the next topic. That is the momentum or linear momentum. Momentum or it is also called linear. Linear is nothing but straight. What is the momentum or linear momentum? The product of mass and velocity of a body is called momentum or linear momentum of that body. Listen very carefully. How to define momentum or linear momentum means, so according to the mathematically, the product of mass and velocity of a body is called momentum. Momentum is denoted by the symbol of P. P is equals to mv. This is the mathematical formula of momentum or linear momentum. Based on this mathematical formula, how we can define the statement means m is the mass, v is the velocity, p is the momentum. That's why momentum is nothing but the product of mass and velocity of a given body, that is called momentum or linear momentum. Generally, so two types of momentum are there. Means when, listen very carefully here, when a body has momentum means when a body is in motion it has momentum, that is either linear momentum or angular momentum. Okay, but if a body is in the rest, it has the momentum or not. So means we know that. For example, we are considering that a body of mass is m. Initially, it is in the rest position. Initially, it is in the rest means the initial velocity, that is nothing but either u or v. So here v is represented the velocity, that is either initial or final. That's why. So according to our example, let us consider a body of mass is m. Okay, that is one. And it's initially it is in the rest means what is its velocity? 0 meters per second. That's why what is the momentum of that body when it is in the rest? According to the formula, F is equals to m into v. M into what is the v? V is nothing but either initial or final. That's why here 0. So that's why m into 0, 0. So what is the momentum of a body? 0. Means what you are understanding that when a body is in the rest position, its momentum is 0. Okay. Now, for example, the same body of mass, it is move with a certain v velocity. For example, mass of the body is 1 kg, v is equals to 10 meters per second. Then what is the momentum of a body of mass 1 kg when move with 10 meters per second? P is equals to mp. M is 1 into V is 10. That's right, 10 kilogram meter second power minus 1. Means here you are observing that when a body is in the rest position, it has the momentum? No. But when a body is in the motion, it has the momentum? Yes. That's why what you are understanding from this simple example means when a body is in the rest position, it does not have any momentum, because of momentum is nothing but the product of mass and velocity. If among the two physical quantities any one will be 0, automatically other one is 0. But mass of a given body is does not 0. That's why you can say that V. So due to that, if m is constant for a given body, so that's why m is constant and equals is there, then what we can use? We can write that P is directly proportional to the V. Means if a body velocity will be increases, automatically their momentum is also increases. If velocity is decreases, momentum of the body is also decreases. That's why which relation we can derive between P and V means these two are directly proportional to each other. Which one? Momentum is directly proportional to the velocity. So what is the formula of momentum? P is equals to mv, that is you know that. Okay. So when we are consider the angular momentum means momentum or linear momentum means when a body is moved in the one dimensional motion. That is either along the horizontal or if a body is moved only vertical. Means if a body is in one dimensional motion, we are consider means the body, listen very carefully once again. If a body is in one dimensional motion, either along the horizontal or in vertical mode. So if a body is moved vertically upward, in this one the body has the mass, and also it is vertically moved upward means it has velocity or not. That's why the body has momentum. That momentum is called linear momentum. Or if a body is already in the motion on the horizontal surface, body means it has the mass and it is in the motion means it has velocity. That's why the product of mass and velocity is called momentum. So this type of momentum we are called linear momentum. Simply listen very carefully. If a body is in one dimensional motion, then it has one momentum. That momentum is called linear momentum or momentum. What is the formula? P is equals to mv. If a body is in the 2 or 3 dimensional motion, means if a body is moved in a curved path or if a body is moved in a circular path, during such type of conditions, what will be happen means it has some momentum. That angular momentum we are called mvr here. Capital L is represented the angular momentum, m is the mass of the particle or body, v is the velocity of the particle or body, and r is the radius of the curvature or radius of the curved path, like that one. Because of the body is moving in a curved path or in a circular path, during such condition it will be how much, it must be how which one, radius. That's why along with mass and velocity we consider which one, radius, in case of which one, angular momentum. But in case of linear momentum we are not considered any radius, because of the body will move in a straight line path either in horizontal or vertical, because of it is in one dimension, it is in two dimensional motion. Anyway, so angular momentum is not our topic. Okay, our topic is what is that one, linear momentum or momentum. So now what linear momentum is a physical quantity, or sorry, linear momentum is a scalar or vector, means it is a vector only, because of it is the product of mass and velocity. For a given body, mass is constant but velocity is not constant. So at the same way we know that according to the multiplication of vector, the product of the scalar and vector is nothing but it is a vector. M is a mass, means it is a scalar, velocity is a vector. The product of these two one we call as a which one, vector, because of momentum means is nothing but so it has some velocity, means the body will be moved in which path, it is a straight line path or whatever that, or it is in an angle. That's why momentum is a which one, it is a vector quantity. Now what are the units of momentum? So SI unit is SI unit of mass is kilogram, velocity means displacement by time, means meter per second, or it is also should be right kilogram meter second power minus 1. This second brings to the numerator side. So mass is kilogram, velocity is meter per second. Then this second brings to the numerator side kilogram meter second power minus 1. And the second one, CGS unit is, so mass is measured in grams, velocity is centimeters per second, or gram centimeter second power minus 1. So that's why the SI unit of momentum is kilogram meter second power minus 1. And the CGS unit of momentum is gram centimeter second power minus 1. Now we are discussing some numericals about this one. Numerical 1 or problem 1. So means I say that simply. A body of mass is 10 kg moves with 50 meters per second. Simple as is that a body of mass is 10 kg. It is moves with 20 kilometers per second. 20 meters per second. What is the momentum of a body? Once again listen very carefully. A body moves with 20 meters per second. Its mass is 10 kg. What is its momentum? So here in that statement they are given two physical quantities. Mass of a body they are given. What is that one? 10 kg. Right, that is one. Next one, velocity is also given. What is the velocity of the body? There says that 20 meters per second. Then you find which value? P value. So means a body of mass is 10 kg. It is moved with 20 meters per second. Find its momentum. That's why we know the formula. What is the formula? P is equals to m into v. This is the formula to find the momentum. But I said very clearly to everyone, before you can solve any numerical or before substitute the values in the given formula, in the formula, suitable formula, what you are observing that what are the physical quantities they are given, the two are in the same system of unit or not, that is either system of international or CGS, means either SI or CGS, both are, first you can observe that both are in the same system of unit or not. If both are in the same system, then automatically you can substitute directly. Otherwise, one is in the CGS, one is in the SI, then you can convert both are into the same system. After that, you can substitute the values. Now here, mass 10 kg, it is in SI. Velocity meters per second. That's why mass and velocity, these two values are in SI unit. That's why directly you can substitute. Then P is equals to, what is the mass? 10 kg into, what is the velocity? 20 meter per second. Then P is equals to 10 into 20, 200 kilogram meter second power minus 1 or second. So this is the momentum of the given body. Means when a body of mass is 10 kg moves with 20 meters per second, at that time what is its momentum? 200 kilogram meter per second. Next, another numerical. A car of mass is 200 kilograms. Listen very carefully. A car of mass is 200 kilograms. It is moves with 72 kilometers per hour. It is moves with 72 kilometers per hour. What is its momentum? So mass of the car is, what is that one? 200 kg, and the car is moves with 72 kilometers per hour. What is its momentum? Listen very carefully here. So a car of mass is 200 kg. It moves with 72 kilometers per hour. What is its momentum? So here you are observing that mass values they are given in the kilogram, means it is in SI unit. But velocity they are given 72 kilometers per hour. What is the SI unit of velocity? Meter per second. But here they are given another node higher than the SI unit. That's why first 72 kilometer per hour you converted into which one? Meters per second. Then what you can do? We know that 72 into 5 by 18 meters per second. 1 kilometer per hour is equals to 5 by 18 meters per second. In the chapter of motion, the relation between, so means how we can convert meter per second to kilometer per hour to meter per second, I clearly explained. That's why 72 into 1 kilometer per hour, that is nothing but 5 by 18 meters per second. So 18 4 ja 72, 4 5 ja 20. That's right, 20 meters per second. So now, mass of the body is SI unit and velocity is also SI unit. That's why what is the formula of momentum? P is equals to mv. Then P equals to, what is the mass? 200 kg into, what is the velocity? 20 meters per second. That's why P is equals to 2 2 ja 4, 1 2 3 kilogram meter second power minus 1. So that's why what is the momentum of the car when its mass is 200 kg and moves with 72 kilometer per hour, means 4000 kilogram meter second power minus 1. Next, the third one. A car moves with 72 km per hour. Its momentum is 2000 kilogram second power minus 1. What is its mass? Listen very carefully. Okay. So, a car moves with 72 kilometers per hour. Listen very carefully. A car moves with 72 kilometers per hour. Its momentum is 2000 kilogram meter per second. What is its mass? Means you can find the mass of the car. So according to the statement, okay, what they are given, velocity is 72 kilometers per hour or km by h. Okay. Next one, momentum is also given. What is the momentum? 2000 kilogram meter second power minus 1, that is given. You can find which value? Mass. That's why you can find m value. So this is they are given. Here we are observing that velocity value is kilometers per hour, momentum value is 2000 kilogram meter second power minus 1. It is SI unit, it is not the SI unit. That's why what I said already in the previous example. So first of all, before substitute the values in the suitable numeric, in the suitable formula of the given numerical, first you can check whether two are in the same system of unit or not. So 72 kilometers per hour, 72 into 5 by 18 meters per second, 18 4 ja 72, that is equals to 4 5 ja 20 meter per second. That's why, so velocity value is in SI unit and momentum value is also in SI unit. Then you can substitute, okay, substitute these two values in the suitable formula. So here, which value given? Velocity given, momentum given. You find which value? M value. We know that already formula. What is the formula of momentum? P equals to mv. But you find which value? M value. That's why V transfer to this side. Then M is equals to P upon V. Means here, some members are confused. V transfer to this side. P upon V is equals to M. Is it correct or not? So that's why, that is I will be writing, okay, directly. M is equals to P upon V. What is the P value? 2000 upon. So what is the velocity? 20. 0 get cancelled. 2 100. That's why M is equals to 100 kg. So means what is the mass of the car when it moves with 72 kilometers per hour having 2000 momentum means so its mass is 100 kilogram. Next, one more thing. Okay. So same numerical we are considering another mode. A car of mass is 100 kg. Its momentum is, listen very carefully, a car mass is 100 kg. It having a momentum 4000 or you can consider it 3000, another value you can consider. A car having a mass 100 kg. A car mass is 100 kg. It having 3000 kilogram meter second power minus 1 momentum, means is nothing but 3000 kilogram meter per second momentum. Find the velocity of the car. One second, listen very carefully. A car mass is 100 kgs having a momentum 3000 kilogram meter per second. Find the velocity of the car. So that's why here which values they are given? M value is 100 kgs, that is they are given, and momentum values are given 3000 kilogram meter per second. You can find what is that one? Velocity. So in the previous numerical they are given velocity and momentum. You find which value? M value. Now in this numerical they are given mass and momentum. You find which value? V value. So I said that very clearly. Before you can substitute these values in a suitable formula of regarding numerical, first you can check whether the given physical quantities they are given in the same system of units or not. Now here mass kg, momentum kilogram meter per second, both are in which one? SI unit only. That's right. So we can substitute directly. What is our formula? P is equals to mv. But here P value given, M value given, we find which value? V value. Now here M value transfer to this side. P upon M is equals to V. So that's why this is simply I will write like this one. V is equals to P upon M. Then that is equals to, what is the P value? 3000. What is the M value? 100. Two zeros get cancelled. That's right. What is the velocity of the car? 30 meters per second. So means a car of mass is 100 kgs is having 3000 kilogram meter per second momentum. That car will be move with how much velocity? 30 meters per second velocity. So this type of numericals mostly they are asking during the examination either for 1 mark or 2 marks. So that's why every student will be okay. So observe very carefully how I can solve and what we can do before substitute the values in a suitable formula based on the regarding numerical. Thank you.